Honestly, phase 6G of this platform development ended up being way more important than I originally expected. At first, this looked like normal routing events. Paths shifted, neighbors changed, traffic rerouted. But once we started digging into it, we realized something really important. The system could have interpreted those operational changes as topology changes, and that's dangerous, really dangerous, because routing behavior changes all the time within a network. But the underlying topology truth should be governed much more carefully. That's really what this phase ended up solving. In our lab, we intentionally caused adjacency changes and route movement across the environment. And you can actually see it directly in the routing tables, as I'll show you here. Prefixes that originally moved through 10.255.3.3 shifted over to 10.255.4.4. Now, operationally, that's completely valid. Networks reroute all the time. But here's the important part of all this. The topology itself hasn't fundamentally changed. And if your platform, which you thought you trusted and you spent a lot of money on, starts treating normal routing behavior like the network itself has been redefined, you can slowly start corrupting your own understanding of the environment. And honestly, that's a much bigger problem than just a general failed route. So what did we introduce here? So instead of allowing discovery or routing behavior to silently rewrite your network topology truth, we introduced lifecycle governance into the platform. Things like review queues, promotion queues, explicit trust states, and operator-controlled promotions. And really what this all means is the system can observe change, the system can infer impact, but the system cannot silently redefine the reality of the network topology on its own. And that boundary matters a lot, and I mean a lot, especially when you're in larger or partially observable environments where you do not see or have control of all the network elements in there. So how do we validate this? And this was really the point for this phase. The route movement happened correctly. The system detected the affected paths. It correctly identified transit impact through R5 or router 5. It even maintained inferred downstream awareness for R7 and R8, but at the same time, the review required stayed at 0, the promotion queue stayed at 0, auto promotion stayed disabled, because the platform correctly understood this was operational behavior changing, not topology truth being corrupted. That distinction is the entire point of what we're doing here. So why does this all matter? Honestly, this feels like one of those more important architectural pivots we've made so far, because most automation problems aren't caused by lack of visibility. They're caused by systems making up bad assumptions about truth ownership. And once the automation starts rewriting your reality incorrectly, the trust that you had in your platform very quickly just collapses. So before you automate actions, before you automate your orchestration, before you automate decisions, you need governed topology truth first. That's what this phase 6G was really all about. So in closing, phase 6G is now formally closed. The next major step is phase 7, and that's where things get even more interesting, because now we start working towards deterministic topology generation. And that's without permanent human maintained seed ownership of the network elements. Now that sounds simple, but honestly is a much harder architectural problem than it first appears. That's where we're heading next. So that's a wrap now for episode 4. But as always, I want to thank everyone for being here with me on this journey, and a big mahalo to everyone.